maybe we can just a little bit start over.
Okay.
Yeah, sure. Thank you. Yeah. Sorry, guys. We'll quickly go through the sessions. Yeah, thank you.
Yeah. Okay, I will just repeat what we have covered until now. So about upgrade VLSI technologies. So as an institute, we are committed to deliver these 4 points. The first one is you can consider it as the best institute for freshers and working professionals for VLSI studies with 100% placement assistance. And second commitment is industry standard tools available with the 24/7 tool access. So each students will be given with the industry standard tool, and the tool is accessible all the times whenever they are enrolling into this course. And third reason could be trainers with a minimum 12 years of experience to provide a quality hands-on experience. So all trainers are 12 plus year experience. Experience in their profession. And fourth one is that training material will be provided to each student, and mock interviews will be conducted after completing the course. And each students will be given with a placement opportunity, and until they get placed, 100% placement support in the sense the training will be given for them to crack the interviews. So this is about upgrade VLSI technologies. And why to select upgrade VLSI technologies? So these are the 4 reasons one can consider. The first one is expert trainers and curriculum. So all our courses are designed and delivered by professionals in the industry who has at least 12 plus years of experience. So such trainers will be selected for providing the quality education. And the second reason could be 100% placement support. The students who passes our exams, so they will be given with placement opportunity, and the required support needed for cracking the interview that will be given by the institute. And the third reason could be the online courses and affordable fees, and all the materials are available, and all the classes are recorded. So after the classes, students can refer back to the recorded videos. And fees are affordable, and EMI facility is also enabled, so students can pay in installments. And a fourth reason could be the powerful EDA tools, like all the tools which are used in industry, the same tools are used during the training. So and the tools are accessible to each students whenever they want. Okay, so these are the 4 reasons why you can select upgrade VLSI technologies for training. So training key information, you will find the content what we are going to discuss in today's session in this link, and the duration is around 16 weeks, and mode of study is weekend online classes. So on Saturday and Sunday, around 3-hour classes will be conducted on Saturday and Sunday. And the tools and VPN, the Cadence Virtuoso tool will be given, and it is accessible 24/7 using VPN network. So the course material, the soft copy is given to each student. If it is needed, then hard copy also can be made. And coming to contact information, so you can mail to us using this email ID, and this is the phone number. So eligibility wise, the students who is pursuing their MTech, ME, MS, or who just completed these courses in VLSI or any other embedded or any other specialization, they can enroll into this analog circuit design course. So, or else the professionals who is into VLSI domain, they might be having 1 year or 2 years of experience, or they might be working in some other domain. For example, it can be verification, or it can be a digital design if they wanted to switch to analog circuit design and they wanted to get started with the analog circuit design methodology, then yes, this is the course, and they are also eligible for enrolling into this course. And industry salary after placement, as a fresher, one can expect 4 to 6 lakhs of salary. With a 3+ year experience, one can expect 12 to 15 lakhs of salary. And in both cases, the job role will be individual contributor. With the 5+ years of experience, the salary could vary between 25 to 30 lakhs. And job role will change to team leader. So here 2 to 3 people will be working under him, under a particular person. He will be leading the team on technical front. So once he gets around 10 years of experience, then yes, he enters into managerial role where he will start managing the people, and one can expect 50 to 70 lakhs of salary with this kind of experience. Placement support, 100% placement assistance will be given to each students until they get placed in any one of the companies listed here. So we have connection with 200+ hiring companies, including product, service, and startups. So few examples are L&T, Capgemini, HCL, and Wipro, Signet, AMD, Synopsys, and many more service companies. And tools will be provided as we discussed in last slides, and the mock interview will be conducted, and then there will be even exams. So once all the training classes are done, then students can get into a placement. And as a fresher, one can expect 4 to 6 lakhs of package. If they have some good amount of experience, like 1 or 2 years, then number might be more than this. So these are the 200+ placement companies we are having connection with. Yeah, so these are the people who got into different companies, who got trained from our institute in a different domains. So this is the content. So there, each topic is divided into different modules. So we are going to have 2 set of classes. One is teaching class, where we will look at the theory part of the circuit, and the second one is the lab class, where we will use the circuit and simulator to realize what we learned in theory class. So in lab class, we will take a few examples of circuits, and we will try to simulate it and try to design the circuit. So we will look at each module one by one in next slide. So total there are 14 modules. So until 12 module, we will look at the design. The 13 module focuses on the mini project, and 14th focuses on the mock interview and personality improvement. So the total theory classes, it's around 74 hours, whereas lab classes has around 30 hours of teaching. So module 1 focuses on device physics. So here the structure and different layers of MOSFET, resistor, and caps are studied in TSMC 65 nanometer. So and then we go to the characterization of MOSFET, caps, and resistors. Here we look at VT, GM, GDS, RDS, and CDS, different parameters. So we will study how it varies with the process, voltage, and temperature. And we will look at a region of operation of both PMOS and NMOS, and the channel length modulation, and ID and VDS characteristics, and how the current varies with the different terminal voltages. We will study in this module. And the MOSFET can be used as an amplifier. Along with that, it can be used as a resistor, or it can be used as a switch. So we will see how to configure the MOSFET to use as a different elements. And then we'll do the AC small signal analysis of a MOSFET, both PMOS and NMOS. And then we will look at short channel effects. So because of a smaller length, what all parameters will change. So we will study that in this section. So this is regarding module 1. Coming to module 2 focuses on the tool. So here first we will introduce Linux working environment. Here we will look at the different Linux commands that are really useful. A few examples are copy recursively, and move. So there will be few set of commands which will be given so that just to operate tool, because Cadence tool will be installed in Linux operating system. So basic commands to get used to Linux, that kind of support will be given in the beginning. And then we'll look at the Cadence Virtuoso tool. So here we'll look at the schematic editor, and we will do different kind of simulations like a transient simulation, AC, STB, DC, and Monte Carlo simulations. So these are the few set of simulations we will be doing. So this is the screenshot of a library manager. So here these are the list of libraries. So each library has a different set of schematics, and each schematic has a different views. So if you open the schematic view, you get this schematic editor. So this is where we draw the circuit. So this is, you people might be knowing all this. So we'll repeat the entire process once again. So in the beginning, and then we will enter into the simulation of the circuits. So module 3 focuses on single stage amplifiers. Here a few set of single stage amplifiers are like a common source, common gate, and common drain. And one more the source degeneration amplifier, where the resistance is connected to both drain and source. So we'll study these single stage amplifiers, and we'll look at the DC and AC analysis of these amplifiers. Even a small signal, we'll do the small signal model, and we will extract all the different parameters like what is the input impedance, output resistance, voltage gain, and current gain. So the theory part we will study in theory class, but in lab session we will try to bias the single stage amplifier, and then we'll try to extract all these parameters from a tool, and then we will compare it with the what we studied in our theory class. So all this input resistance, output resistance, voltage gain, and current gain, so those can be extracted through simulations from this single stage amplifier. So in simulation, we will extract all these parameter, and we will compare it with these equations, and we will see how it matches with these equations. And module 4 focuses on differential amplifier design. Here we will look at the basic concepts like what is single stage and differential signals, and why we focus more on differential signals. And we will take the 5-pack differential amplifier, and we will do the small signal and the large signal analysis of this 5-pack amplifier, and we will do a plot, the Bode plot, and we will do the pole zero calculation, and then the sleeve rate and PSRR, like the different parameters we will study for this circuit. So along with this, we will look at different current mirrors. For example, the cascode current mirror and low voltage cascode current mirror. So this kind of current mirrors also we will be studying in this module. So module 5 focuses on feedback techniques. So here in this module, we'll study the negative feedback, and what is loop gain, and how to write the transfer function of the feedback system. So that we will study. And again, we will look at a pole zero plot of a system using this loop gain, and we will study the Bode plot and root locus techniques. And we will look at different parameters like what is phase margin and what is gain margin, and in a feedback systems to make it stable, then what kind of phase margin and gain margins are needed. So those studies we will do in this module. So module 6 focuses on stability analysis. So here we will take a low pass filter and high pass filter. Few examples are like a LC circuit or LR circuit. So, or it can be RLC circuit. So we will take all these circuits and we will do the time domain analysis, and then we will do the frequency domain analysis. And we will look at its time, a few basic things like what is time constant for the step response, how the output settles, those kind of studies we will do for a single order and second order circuits. And then we will go to domain to pole approximation for second and third order systems. So if you take any op-amp circuit, there will be only one pole that lies within the UGB. So all second and third poles are pushed outside of UGB. So why it is like that? So that kind of studies we will do in this section. And then we will take the circuits. Yeah, this is one common source amplifier, and we'll plot the frequency response. We'll plot the frequency response of this amplifier. So along with this, we will take many other single stage amplifiers which we studied in previous module, like common drain and common source and common gate amplifiers, and we will write the frequency response of these circuits. And then we'll study the Miller theorem, and it's a Miller effect. So how a Miller theorem helps to stabilize the circuit, that study also will do in this module. So module 7 focuses on operational amplifier design, or OTA, operational transconductance amplifier design. So here we will study different OTA architectures, and a few examples are telescopic cascode OTA and folded cascode OTA. And we'll take these two architectures along with this 5-pack 5 transistor OTA, and we'll write a small signal and large signal model, and we will study different parameters like the sleeve rate, power supply rejection ratio, and we do even Bode plot and pole zero analysis for these amplifiers. So along with that, we will study even the mismatch. So how the layout of the circuits needs to be done, and what all the layout guidelines which designer supposed to provide to layout designer. So those studies we will do in this module. So module 8 focuses on LDO design, and module 9 focuses on band gap design, and module 10 focuses on oscillator design. So the basic concept will remain same. Here we will take one architecture for LDO, and one architecture for band gap, and one architecture for oscillator. And we will do the small signal model, and then we will make it stable. And then specific to each architecture, we'll study one parameter, a few set of parameters. For example, for LDO, the transient and line regulations are important. And for band gap, the PTAT and CTAT, the temperature curve fitting is more important. So those concepts we'll study in band gap design. And in oscillator design, the stability we do not care. So the plan is to make it unstable, so it oscillates with a given frequency. And we'll take 2-3 architectures and we will see the differences. And then we'll run a few simulations on each these IPs. And after studying the basic design concepts, then so there will be some assignment. So students needs to design LDO, bandgap, and oscillator. It will be a small assignment. So once that is done, the students will be given with the interview and key questions on design and layout. It will be more like a few set of questions which usually asked in interviews. So those questions will be given, and there will be some quizzes will be conducted on this. So yeah. So module 11 and 12 focuses on a PLL. Module 11 focuses on PLL, whereas module 12 focuses on data converters. So initially, in case of PLL, we will do mathematical model of VCU and phase detector, and the problems of phase alignment and response to frequency step, response to phase step. So these we will study. And then PLL dynamics, type 1, PLL, type 2 PLL, and PLL design procedure and charge pump design. So these we will study, and charge pump will be a part of a PLL, but we will study 2-3 architectures of charge pump, because charge pump is used in many other circuits. So the different context. So we will study even that charge pump different architectures. And so interview questions will be given on PLL, and necessary assignment will be given to make sure that students understands the concepts which is taught in theory class. Similarly, for data converters, here we'll look at only the overview of different data converters, and we'll study a few dynamic parameters of EDC, like signal to noise ratio, total harmonic distortion, and So here we will not be doing extensively the design of data converters. So instead, we will look at only the overview, and to cover to understand all these parameters, few assignments will be given on data converter. And once that is done, we will focus on mock interviews, and personality development classes will be conducted. So in this module, we'll look at a resume building, and as I said, mock interviews will be conducted, and personality development classes will be conducted. And once everything is done, test will be given, and course completion test will be conducted, and a course completion certificate will also be given. So once that is done, student will be given with the placement opportunities, and necessary support is given from our side to crack the interview. So this is all about different modules. So if anyone has any questions, then yes, you can ask.
Hi, my name is Dinesh.
Yeah, Dinesh.
So, you never mentioned about what will be the different devices that will be in an available in a technology library that mostly we'll be using. Not every devices. Like in which scenario we'll be using them. Like there will be mom cap, CRT moms, and also NMOS caps. When will like characterizing device is also important, right?
Yeah, that is correct. So in the first session itself, we'll be doing that. For example, just give me a minute. So the module 1 focuses on that. Here we will look at all the available MOSFETs, resistor and capacitor, and we will extract all the parameters like a VT, GM and JDS in case of MOSFET. In case of resistor and cap, we will look at its variation across process temperature and voltage. So, and we will look at the structure. So this is the one example for MOSFET. Similarly, we will look at a resistor and cap structure, and we will try to understand whether it is a metal cap or a P-well cap or N-well cap or P-well resistor, metal resistor, and those kind of studies we will do. And we will list out which all kind of these resistor are used in which applications. So that kind of studies will be done in first module itself.
And also,
And
apart
then, yeah.
Please.
Yeah. So once the characterization is done, then we will pick the best that is suited for a given assignment, because each technology will have a different voltage ratings. There will be many MOSFETs with a different voltage ratings. Some can be 0 to, some can be 1.2 volt, or some MOSFETs can be 1.8 volt rated. Some can go even 12 volt. So assignment will be given. So according to that, students need to select the appropriate device and try to design that circuit for a given spec.
Since you mentioned that this TSMC 65 nanometer, will there be any PDK document through which we can figure out like which devices will be underdriven, overdriven, and different model parameters for each device, like ULVT, SVT devices, from where we can use in respective application?
Yeah. So like regarding the device rating, like the voltages and currents rating will be given in a document. So when the TSMC 65 nanometer technology is installed, so there is something called process development kit, PDK. So that that folder will have all the details of MOSFETs which are present in this technology. So from that technology file, we'll get to know about all the ratings of MOSFET resistors and capacitors.
Okay, and also like starting from device physics until differential amplifiers, so there'll be a lot of theory and a lot of architectures to study. Will we get enough time to implement these circuits at least?
Assignments, just to make it familiar, assignments will be given like time-wise. Definitely from student side, they have to put a lot of effort, because since only the classes will be conducted during the weekends. During the weekdays, they need to put some extra effort and do all the assignments. So the focus of giving assignments is to doing more extra work and covering more architectures. Because in theory class, we will take 2-3 architectures, and few more architectures will be given as an assignment.
Okay, and also this, like starting from this LDO, like op-amp LDO, BG, PLL, and ATD. I thought like even if you consider an LDO, we won't be able to cover maximum of LDO concepts in a 3 hours lecture. And that's what I think. Like I tried to research for this LDO, and like I have some knowledge, but I believe, and moreover, I was looking for in a course where like extensively study of one block. You understand, right? What I'm trying to say.
Yeah, got it. So see, LDO, if you take LDO architecture itself, there will be hundreds of architectures. So what one student can do is, there will be a mini project, right? So if you look at the module 13, it covers the mini project section. So if someone interested in LDO, then they can do the project on LDO alone. Like they did not work on bandgap or any other IPs. So they can focus only on LDO, and there he can do the extensive study. But as a analog circuit design engineer, one should know the overview of all the IPs.
Yeah, considering from LDO, BG, and oscillator, and moving on ahead, I think this will be like a more of a theory concept classes rather than in implementation level, right? Because we'll not be able to cover much of the things even if you consider this BG also, startup takes a lot of time, more architectures in startup and different application requests, different startup. And based on the technology node, we use also startup changes and the circuitry for BG changes and the op-amp inside it changes. Like they're like the deeper we go, like more concepts to be studied theoretical itself. I think, I believe, like, yeah, please go on. I want to stop there. Sorry.
No, see, definitely, if you want to study everything in depth, then it will take years. You know, right? So if
Yes,
you
yes,
take
yes.
even take one LDO design, it will take ideally 6 to 8 months if you start from scratch. So this is the fact.
Yes, yes,
And even if you take band gap, there will be so
yes,
many things
yes.
to understand. So the intent is like, so we know many things. So we will try to consolidate everything, and we are trying to put it in a right manner. So only those concepts which are really important, it will be taught in theory class. And the assignment is completely a design of band gap. Okay, so in lab session, students needs to work on this, rake up the circuit and start running the simulations, and and they should try to design the band gap or LDO in lab session. So in that way, theory definitely we have to study, no escape from that. If you have experience in LDO, then it will be much more easier for you. So most of the time you can spend in lab instead of theory. So theory is must to do it. Along with that, here in this course, we are focusing on even lab. So that kind of training you will not get in college, that's for sure, because there almost 90% focus will be given on only the theory, whereas just 10 to 20% on lab simulations or the design. But here it is other way around, because you have already completed your BE. It means that you don't need a solid like a repeating RLC circuit, repeating the MOSFETs. You are focused more on the design. So in that way, this course will be much more better and matured compared to what you study in college.
Okay. So will there be another courses which will be concentrating on only single block, like a total course on a PLL, or total course on only just or a analog converters, data
Uh,
converters, something like that?
right now, no.
Post this.
We don't have because see, very few set of people will be interested in only one IP. So right now we don't have that courses separately for each IPs. Yeah.
Yeah,
And
that's
one
it.
more is, see, this course is meant for people who is having 1 or 2 year experience. So do you expect them to know everything? The entire LDO design, entire band gap design, entire, no, right, definitely. The students and the professional who is having 1 or 2 year experience, they know the overview first. And they worked on 1 or 2 IPs like a LDO and band gap, and they have some in-depth knowledge about max 1 or 2 IPs. It will not be more than that. It's like that.
Okay, thank you. That's all I wanted to ask. Thank you.
Okay. By the way, how many years of experience you have? Or
No,
are you a final year student?
no, I have completed my PG. I used to have this access for TSMC 45 nanometers in my college, and I used to spend more time in lab itself. So I try to work on this BG op amp I have done, and using that I try to build this LDO, and I try to simulate like build a basic PLL from Razavi and try to simulate that. I was just experimenting, and yeah, so I thought I could go ahead more. So I just wanted to learn more. So
Okay. So what about your final year project? You worked on what?
yeah, I have done in the part like as a class, we try to design this trans receiver where we try to place LNA, a lot of other blocks. which will be a part of trans receiver, right? So we were assigned with each of person with one of the blocks of this transceiver, for which I was supposed to design this band gap. So yeah, that's how it went. Apart from that, all the other blocks I try to learn on my own and try to implement and see how it goes and how much time, what are the parameters. Yeah. So
Then you know, right? Once you study band gap something, but once you start uh, running the simulation, you will start seeing other problems. For example, bias margin. So the
Yeah.
band gap should work across PVT. So that kind of study you will not do in theory class, right? Bias margin you will never study.
Yes, yeah. That's
So yeah, so that kind of like a design we will do in lab course. So the assignment is meant for students to get that experience. Once they start designing, then they will start seeing the different problems.
okay. Yeah. Yes.
Okay, thank you, Dinesh. Any more questions?
Yeah, that's all I have, and I don't think anybody else is in there to ask.
Okay. Okay, then thank you all. Like you know whom to contact, right? Like if you guys are interested, then you can contact Bhuwana. And by the way, the classes will start from next week. This week only it started, but it will be more like an introductory class. So the actual classes will start from next week for your information. Okay, thank you. Thank you all.
Yeah, thank you so much for this.